Okay, we are going to look at the 2016 question on titration maths. Now, usually we ask you to do it via first principles. I'm going to show you a slightly different way that may or may not float your boat. So, usually I ask you to do your W maths, your first principles, and your maths titration, and then we see where we're at in terms of the question. The first thing, though, that we always do is we always work out our data table. So we are looking for A is what's in your attic, so in your burette, and B is what's in your basement, which is in your conical flask. And if you can use that terminology for A and B, that will help you no matter if it's a redox titration or a water titration or an acid base. It will all hold. So there is a little kick in this question in terms of the way in, but we'll see where we go. So the first thing that we need to do, please, is figure out what is the details that we have for the acid. And I think I'm just aware, no, I have done it. So the acid was our vinegar, and for our titer volume, we have 18.75 centimeters cubed, and there doesn't appear to be a big M value there, so I'm putting in 18.75. My ratio from the equation here is inferred, and it is 1. I look for my base information now, and in terms of my base information, the thing that I have is 25 centimeters cubed. There is no big M value, it looks like, and the number 1 is inferred here. So I'm putting my 25 and I'm putting my 1. Now, there is no obvious way in here. Usually we'd have a big M value in one of those columns and there is no way in. But there is extra information. So there's 2 pieces of extra information for this question. There's 25 centimeters cubed of vinegar goes to 250. So that is looking for a dilution factor later on when we get there. And the other piece of information is 1.2 grams of NaOH. And that is made up to 500 centimeters cubed. So one of those pieces of information is our way in, and this is what we can use to get our way in. So we can turn this into being able to use it in a mass triangle, but the first thing that we have to do is we have to move it to grams in 1,000 centimeters cubed. And once I've done that, I can now put this into my mass triangle. So NaOH, when we do it, is Na is 23, oxygen is 16, hydrogen is equal to 1. So 23, 24, and 16, I can do this in my head, is 40 grams. So for my mass triangle, I would have 4.2 over 40. And when I do that piece of maths, I get 0.06, and this value is now I'm going to put up into here for my base. So this had a little kick. If you cannot calculate this number, you just literally put in a number, and if you want to write a note for your examiner saying, can't figure this out, I'm going to do my maths with this number, away you go. So we have our data table. We would usually do our first principles, and I'm going to show you the calculation for the old school way of doing titration, finding the big M value for our acid. So this is the equation that used to be used. So V1 over M1 is equal to V1 M1 over N1 is equal to V2 M2 over N2, and we fill in what we have. So we have 18.75 by M1, because that's our question mark, over 1 is equal to 25 by 0.06 over 1. And now we're going to solve for M1. So to do that, this has to come onto the line and this has to come over the line. So we're going to put it all in. So M1 is going to be equal to 25 by 0.06 by 1 divided by 1 by 18.75. Now when we do that, we are getting 0.08 big M. This is our diluted vinegar. We've got a final concentration of this. The other thing that we've always asked you to do is do your mass triangle. So this is ethanoic acid. It is CH3COOH. So it's going to be 12, it's going to be 1 by 3, 12, 16, 16 and a 1. And when I multiply those all up, we get a molar mass of 60. So multiplying that by 60, I get 4.8 grams per 100 centimetre, 1,000 centimetres cubed of our diluted vinegar. So we did this without ever looking at what is it that the question wanted. So going back up to the top here, the question is asking me number of moles of sodium hydroxide in each 25 centimetre cubed portion. Now that piece of maths has not answered that question, so we are going to need to do something with this. It also asks for the number of moles of ethanoic acid per centimetre cubed of diluted vinegar. This method does not answer that. Find the concentration of ethanoic acid in terms of the original vinegar. We haven't done that, but we can do that from this particular number now. So using this 0.08 mole of diluted, we can now figure out D part I. So if we were to do that, we need our dilution factor, and our dilution factor in this instance was 250 divided by 25 is equal to 10. So I would just multiply 10 by 0.08, and now my original vinegar is 0.8 big M. So I've now answered D part I. So I just annotate it up. I don't rewrite anything because I may make a mistake. The D part 2 is a percentage weight per volume. And again, I'd be the richest person in the world if everyone knew what percent weight per volume means. So this means grams per 100 centimetres cubed. Currently, over here on my right-hand side, I have grams per 100 centimetres cubed of diluted. So how do I work that up? My percent weight per volume is in original, so I will literally again multiply this number by my dilution factor, which will give me 48 grams in 1,000. Apologies, and if I want to now transfer this to this, I would just go 48 divided by 1,000 multiplied by 100, and that will give me 4.8 grams per 100 centimetres cubed, which is the exact same as saying 4.8% weight per volume. So for this particular question, my very short method of using this old school V1M1 over N1 is equal to V2M2 over N2, I was able to work out these pieces. So how do I figure out now C part 1 and C part 2? So what pieces of information do I have that I can help? I know from my data table that my big M value for NaOH was 0.06 moles. Big M, apologies. It's asking me for moles in 25 centimetres cubed. So 0.06 big M is equal to 0.06 moles in 1,000. So if I wish to find it, what is my N value? I would literally have to do my first principle maths, or you recognize how many times 25 goes into 1,000. But I'm kind of old school, so 0.06 divided by 1,000, which is what we would have done in our first principle maths, and now I multiply it by 25, and when I have done that, I would get 1.5 by 10 to the minus 3 moles in 25 centimetres cubed. This is our first principle maths. It is our fourth triangle, essentially CV over 1,000. And in terms of the W that we do for our maths, this portion, the piece of maths we just did was this from our first principle maths. In the part 2, it's asking us for moles of ethanoic acid in a centimetre cubed. So the piece of information I have in my diluted is the 0.08 moles of diluted vinegar that we worked out using my new old titration equation. So again, if I want to find out what's in 1 centimetre cubed, I would be taking the 0.08 big M and I would be dividing it by 1,000, and when I do that, I get 8 by 10 to the minus 5 moles. Now, just for interest, again, when we do our titration maths, what's in 1 centimetre cubed, this would have been what we would have done from first principles. It may be that this V1M1 over N1 up here is going to help you to float your boat, but you are still going to be using the maths that's involved with first principles to work out down here this answer and this answer. But as I say, it may float your boat, so if it does, then please give it a go.